Okay, simultaneous equations by substitution. You'll notice that the equations are written differently than the elimination method. Notice it starts with y equals some x's and y equals some x's, whereas in elimination you usually see, say, 2x plus 3y equals. Okay, so that is a big clue as to which method the question is set up for. But as I just said, you could always use the substitution method by changing the subject. Substitution, the name sort of gives it away. What I'm going to do is everywhere I see a y, I'm going to put an x. That's because I know that y equals x. So I'm going to put, in effect, equation 2 into equation 1. That's my step. So writing out equation 1 reads y equals, but instead of putting an x, instead of putting the x in, I'm going to put in y. Okay, so 2, so I'm just writing out equation 1 as I see it, but instead of putting an x, I'm putting a y because I'm substituting what y equals. If y equaled x minus 1, I'd put, sorry, if x equaled y minus 1, I'd put y minus 1, but it just equals y. So I've substituted 2 into 1, and notice, you'll know if you've done it right because you'll get a new equation that only has one variable in it. Notice my new equation only has y's in it, and I can, whenever you have an equation with one unknown, you can solve that equation. So, looking at this, I'm going to collect y's where there's more of them on the right hand side. So I'm going to subtract y from the left, 1 y from the left, and I'm also going to subtract 1 y from the right. That will give me 0 equals y minus 1. Right? Took 1 y off one side, took 1 y off the other side, still in balance, and I'm almost solved for y. Right, to get rid of a minus 1 on the right hand side, I'm going to add 1 to both sides. 1 equals y, or y equals 1. Just repeating that, all I've done is I've substituted into equation 1, equation number 2. Okay, looking here. I've just put what x equals into there. So instead of putting x there, I've put y, and that's all I did. So that equation and that equation are the same, only instead of putting x there, I put y, because we know that y equals x, or x equals y, right? So I just substituted it in. And then I solved that equation, because it's only got one unknown, and I got y equals 1. Oops. And what if y equals 1, what must x equal? 1 as well. Good. Because x equals y, y equals x. So x also equals 1. So there are my final solutions for that example. Watch this example. I've got y equal to 6 minus 2x, and x equal to y plus 1. I'm going to put 2 into 1 again. Right? That's my step. 2 into 1. So in other words, anywhere I see an x in 1, I'm going to put y plus 1 in brackets. So writing out equation 1, y equals 6 minus 2, but instead of writing the x, I'm going to write what x equals, y plus 1, because I'm substituting equation 2 into equation 1. Right? One equation now, with one unknown, I can solve that equation. Right, solving y equals 6. Now, expanding this bracket out is minus 2 times y and minus 2 times 1. So it reads minus 2y minus 2. Keep going. Just simplify those two terms because they're like terms. 6 minus 2 is 4 minus 2y. Now where are there more y's? On the left hand side or the right hand side? They're actually more on the left. Okay, there's negative 2 on the right and positive 1 on the left. Therefore, collect where there's more. So in other words, I'm going to add 2y to both sides because I want to undo that. So that's my step now. Add 2y to the left hand side, I get 1y plus 2y. 3y on the left hand side. And when I add minus 2y plus 2y, the y's are cancelled from the right hand side. And the last step is to divide both sides by 3. 4 over 3 is the value for y. Come back to the start. So remember y is 4 over 3. Put 4 over 3 in for y. That will solve for x. Okay, so it's the same process as the elimination. Once you find one variable, you substitute that back into the one of the first two equations to find the other. So finding the other here, x must equal 3 over 4, oops, sorry, 4 over 3, that's better, plus 1, I think that's 7 over 3. Or is 7 over 3. Or you could have written 1 and 4/3 would have been fine. So question 2 looks like this. Equation 1, equation 2, and I'm going to put, I can go 1 into 2 or 2 into 1. In this case it doesn't matter, but I'll stick with what I've been doing, 2 into 1. So I'm going to write out equation 1, but anywhere I see an x, I'm going to write y plus 3. Okay? So 2 goes into 1. So first term is going to be y plus 3. And carry on writing out equation 1. 2y minus 5. One equation, one unknown. I can solve that equation. There are y's on both sides of the equation. Collect the y's where there are more of them. So there are more on the right hand side. So I'm going to subtract this positive y here from both sides. So do this to both sides, subtract 1y. So in other words, on the left hand side I'm left with 3. 2y minus 1y on the right hand side is just 1y. Still got the minus 5. And the idea is to isolate y. So I want to shift next the minus 5, so y becomes by itself. To shift minus 5i. How do you shift minus 5? Plus 5, both sides. Both sides of the equation. And y is equal to 8. 5 plus 3. right? So I added 5 to both sides. Once I've got one solution, I then put that solution back into one of the equations. Equation 2 looks the simplest, so put y equal to 8 into equation 2, and x must equal 8 plus 3, which is equal to 11. So my solution is y equals 8, x equals 11.